Welcome to the channel, especially to our new subscribers. Today we shall continue to discuss braking test. Our discussion will include diagnostic checklist if the braking effectiveness is too low or if the brakes are too weak. The brakes are too weak. Say braking effectiveness is less than zero point 0.3, then the main issue related to braking system deficiencies are: number one, worn out brake or pads or shoes, which will result in reduced friction between the surfaces, thus resulting in poor deceleration. Number two, glazed or contaminated linings. Oil, grease, or overheating leads to slick surface, thus resulting in weak grip. Thin or overused brake drum or brake disc. It also decreases effective contact or causes brake fade. Improper brake adjustment, that is, excessive free play or imbalance between front and rear braking. The issues related to hydraulic or mechanical faults are: number one, air in hydraulic lines. Compressible air reduces hydraulic pressure and resulting in spongy brakes. Low or leaking brake fluids, responsible for inadequate force transfer, resulting in brake fade or failure. Worn out cables in case of mechanical brakes results in slack in cable, thus resulting in delayed or weak braking response. Issues related to thermal effects. Number one, overheating of braking components. Overheating reduces coefficient of friction, which results in dramatic drop in stopping power. Repeated braking without cooling. In this case, heat builds up, which causes fade in lining and fluid. By fade in lining, we mean brake lining fade occurs when the friction material, brake pads or shoes, gets too hot. As a result, the material loses its friction properties and braking effectiveness, reducing significantly. This means you have to press the this means you have to press the brake lever harder to achieve the same stopping power, or brake feels spongy. Number two, fade in fluid. In hydraulic braking system, braking fluid transfers force from the lever to pads. If the fluids get too hot, it can start to boil, forming vapor bubbles. These bubbles compress easily, causing a drop in hydraulic pressure, leading to brake fade or failure. This brake lever may feel soft, or braking response becomes delayed. In case of braking effectives too low, issues related to poor contact or friction characteristics are: number one, improper or inadequate contact between pad and drum or disc. Uneven wear or misalignment reduces effective braking. Number two, low friction brake material. Material with inadequate friction coefficient under load results in poor performance of braking. Issues related to assembly and installation. Number 1. Incorrect lining fitment or riveting. This causes movement or poor engagement. Number 2. Wrong brake type or part installed. That is, say soft lining on heavy duty use. A soft lining is made of lower friction, more compressible material which wears more quickly but often gives quieter and smoother braking under normal conditions. However, soft linings are not suitable as they compromise safety, consistency, and durability under stress, say while you are driving in hilly areas. Other factors related to external or test specific factors are: number 1, wet or contaminated road surface. It reduces friction, thus requiring longer stopping distance. Number 2, improper tire pressure. It affects grips and braking efficiency. Number 3, overloaded vehicles. Overloaded vehicles have more inertia, thus they have greater braking demands. There could be some measurements error too, incorrect speed or distance, or in case of environmental factors, which may be responsible for the skewed results. Therefore, in case of peak brake list, summary of our diagnostic checklist would be: number 1, brake pad shoe condition. Number 2, brake actuation system, hydraulic or mechanical. Number 3, brake fluid level and presence of air. Number 4, contact surfaces. Number 5, any contamination like water, etc. Number 6, loading and speed measurement accuracy. Here is the summary of diagnostic checklist related to weak brakes and in case when braking effectiveness is less than 0.3. These four factors we have discussed related to brake system deficiencies. These three factors, that is air in brake lines, leaking or low brake fluid, slack or stretched brake cables, we have discussed, which are related to hydraulic or mechanical faults. The issues related to thermal effects are excessive heat buildup during repeated braking and brake fade due to lining or fluid. The issues related to contact and friction are poor contact between pad and disc and drum, low friction or incorrect braking material. The issues related to assembly and installation are misaligned brake components, wrong or incompatible parts installed. The external factor which could be resulting in lower braking effectiveness are wet or dusty surface, underinflated or overinflated tires, overloaded vehicles, or incorrect speed or distance measurement. Here are some recommendations related to service. Inspect all friction surfaces and replace if worn or glazed. Check for hydraulic integrity, no leaks, proper fluid levels, and ensure that there is no air. Test for brake balance between front and rear systems. Ensure that correct and standardized test conditions are met. And use only approved brake materials for the given applications. Here are the two graphs related to speed retarding rate and braking effectiveness versus speed. In graph 1, it shows how the retarding rate B increases quadratically with speed, assuming a constant braking distance. Likewise, graph 2 indicates that braking effectiveness also increases with the speed as it is directly proportional to the retarding rate. Here the graphs also related to speed retarding rate and braking effectiveness versus speed. Speed is at the horizontal scale, whereas the speed retarding rate and braking effectiveness is on the vertical scale. Previously, we had shown this relationship in the shape of bar graph. Now it is shown in the shape of line graph. Here are our comments on brake test. The brake test is not just a procedural requirement. It is a safety critical evaluation that ensures a vehicle can stop effectively under real world and worst case scenarios. It provides measurable and reproducible data for vehicle performance, safety compliance, and brake system validation. It is foundation to both design feedback and regulatory approval. The benefits to manufacturing companies. The benefits to many manufacturing companies include number one, product safety validation. The test confirmed that the vehicles meet minimum safety thresholds before going to market. Number two, quality control benchmarking. It detects production variation or defective parts during line testing. Number three, it provides input to engineers for improving braking components and its layout. Number four, regulatory compliance. The test ensures conformity with national and international standards. Number five, marketing and customer trust. Strong brake performance can be marketed as a safety feature. Number six, warranty reduction. The test identifies issues before sale, reducing post-sale repair costs. Some additional comments related to braking test. Number one, front versus rear braking contribution. In motorcycles, front brake contributes 60 to 70% of stopping power. Testing often involves both field performance individually and in combination. Number two, dry versus wet condition testing. Regulatory testing often includes wet surface testing, where performance must remain within the safe threshold. It assesses the water shedding ability of the pads and the disc and drums. Number three, brake fade testing. Tests are repeated multiple times to observe brake fade, that is, loss of effectiveness when heated. It is important for mountainous terrain or heavy duty use. Number four, measurement accuracy. Accurate speed sensor and stamping equipment are critical. Number five, data used in simulations. Braking performance data is often used in vehicle dynamics simulations and virtual homologation. Homologation refers to the official approval or certificate of a product, process, or system to ensure that it meets regulatory standards, legal requirements, or technical specifications, usually in a specific country or region. The brake test is foundation tool in both vehicle safety engineering and production quality control. When used alongside costing, acceleration, and fuel economy test, it provides a holistic view of vehicle performance. What is special about the braking test? The braking test is just not a routine test. It is a crucial safety evaluation that delivers actionable insights. It provides objective measurement of real-world braking performance under controlled and repeatable conditions. It reveals whether braking systems meet or even exceed minimum deceleration standards. It provides engineers with data to optimize brake components like caliper, hydraulics, ABS, tuning, and weight distribution. It lets manufacturers compare their vehicle directly against leading market standards. It picks up inconsistent batches or manufacturing defects before products go to the market. It is clear, documented proof of performance which helps in regulatory approvals and strengthens market claims. Why braking effectiveness is important. Number one, safety baseline. Value closer to E, say E is 1.0, signal exceptional braking performance. Number two, model differentiation. Higher E position brands as leaders in safety and engineering sophistication. Number three, product development feedback. If we track the numbers of braking effectiveness E, if it number, it helps you in prototype testing and drives continuous improvement. Number four, marketing leverage. Promoting high numbers underpins performance claims and bolsters brand trust. Here is the comparison chart showing the comparison of the braking effectiveness value E of some top brands. Number 1. Honda CBR Fireblade. Its braking effectiveness value is 0.95. Number 2. BMW R1150GS with ABS brakes. Its braking effectiveness value is 0.81. Number 3. Suzuki GSX-R 750. The braking effectiveness of this model is 0.82. We can conclude, we can interpret that Honda Fireblade achieves nearly 1 G of deceleration, which is indicative of top-tier emergency stopping power. BMW and Suzuki follow closely with excellent historic braking. These E-scores, which are closer, which are close to or above the zero point 0.8 threshold, they are all indicative of sport bike grade emergency braking performance. Here is another chart of brand comparison related to braking effectiveness. BM brand BMW with non-ABS brakes has the braking effectiveness value of 0.67, which is acceptable. BMW with ABS equipped brakes, it has the brake effectiveness value of E as 0.80, which is a superior performance, which is an indicator of superior performance. Ducati Monster has the braking effectiveness of 0.63, Yamaha FZ6R as 0.63. Both are street bikes, and their braking effectiveness value of 0.63 is indicative of solid performance. Harley Davidson, it is a cruiser style motorbike with braking effectiveness value of 0.56, which is acceptable. KTM 300 Duke, it has the braking effectiveness value of 0.60. It is a lightweight motorbike and has strong brakes. Here is a comparison table showing the comparison of braking effectiveness of the motorcycles and scooter produced in the countries like India, Japan, Bangladesh, Pakistan, China, and Italy. The 150 cc capacity motorcycles produced in India have the braking effectiveness value of 0.87, which is indicative of exceptional performance. The heavy bikes produced in Japan have the braking effectiveness value of 0.59, which is also indicative of solid performance. There is no comprehensive public data available related to the motorcycles produced in Bangladesh, Pakistan, China, and Italy. Key takeaways: Indian motorbikes 100 and 150 cc have exceptional performance with the braking effectiveness value of E of 0.87. The Japanese heavy bikes with E value of 0.59 are indicative of solid performance. No countrywide E database exists for Bangladesh, Pakistan, China, or Italy based on public or academic sources. Our key observations are Honda high-end motorbikes, they can achieve the E value up to 0.92. Standard ABS equipped model can reach the value of E from 0.86 to 0.92. Commuter scooters like Honda S-Wing with ABS brakes have the E value of 0.6, 0.6 to 0.9. All these values are indicative of excellent braking performance. In case of Yamaha MT-09 shows a broad effectiveness range depending upon testing context. TDM 900 can score the E value of up to 0.85, which is also indicative of very good performance. Suzuki middleweight bikes, they can register an E value of 0.88, while the sport focused motorbikes can reach up to E is equal to 0.97 on the dirty track. These are also indicative of very good performance. Published data of Piaggio scooter and Chinese Pakistani model is not available. Although we have shown the braking effectiveness value comparison table for different brands, models, and for different countries. But full national comparison is not possible due to different reasons. Because the braking effectiveness tests were conducted and are related to model specific. Therefore, the across the table comparison is quite difficult. The number two reason is test variability. Difference in test speeds and load conditions, ABS presence and tire setup make direct country comparisons unreliable. Manufacturers' third reason is manufacturers, OEM, and testing agencies rarely published aggregated e-stats by country. With this, we conclude our today's discussion on the subject of braking test. Please do drop your comments and share your experience. Our next topic of discussion would be 10,000 kilometer speedometer endurance road test. In the meanwhile, stay tuned and don't forget to like, share, and subscribe to receive the similar contents in future too. Thank you and thank you very much.